In dealing with Polya's 4 steps to problem solving, the name here and the fact that it's attached to someone as important as George Polya might make you think that it's really complicated and ocean-esque plan with tons of moving parts that you have to get exactly down right to the perfect level.
You guys are pros. The best.
You're right. He's right. Ruben, you're right.
But no, not really. I mentioned in the introduction, it's actually very basic stuff here. That these steps we have are essentially that you start by understanding your problem. And what this means is you go in, you read through carefully, you see what you're given and what sort of things you're looking for, and you just figure out what it is that you actually want to do very carefully. Because usually these things are either actual problems that you have, or in the context of homework, quizzes, and exams, word problems. And with a word problem, you're often going to have more information that you need. Sometimes you're going to have less, as we're going to see in a couple minutes. But a very important part is always to be able to tell what it is you actually want and how you plan to get it. Where once you see those things, then you talk about actually doing the thing. Where you make your plan, and yeah, this, like I said, it's not the very best there. It's got sort of that draw the rest of the owl problem in the sense that making the plan, sometimes it's obvious, sometimes it's less obvious. I guess it's not super helpful to make the second step just do most of the work. But essentially what we want to do here is think about some of the ways that you can approach a problem like this. Think about some of the things you could do in terms of inductive and deductive reasoning to look for patterns, or organizing information into lists and tables so you have a very clear picture of what it is that you're looking for. Then maybe try and simplify things by tossing out extraneous information, or maybe make a guess. Because often in math problems, if you understand what you're looking at, you can just take a guesstimate and that'll help you get a sense of where you're supposed to be. Or use some trial and error from there if you want to make your guesstimate a little bit better before looking on. Make some diagrams, use common sense, or maybe just think of some tricks that you can use to try and get around the center of the problem. We'll see how we can use different things like this to solve problems, as it were, to make our plans. And then once you have the plan, you do it. You know, if you want to do guess and check, you guess and check a little bit. If you're going to use something inductive, you think about what you're going to be drawing your conclusions based off of. If you want to make a diagram, then you make the diagram. But part 3 is all about just carrying out the process as you see fit. And then finally, you want to check your work. Because sometimes these are very, very simple problems where it's like, if I give you 5 apples, how many apples do you have? You don't have to do a whole lot to figure out that you have 5 apples. But there might be more moving parts than that, and it can be very easy to misplace simple details along the way. So, to understand this before we actually carry out the 4 steps properly in a problem, let's see how it might go wrong. How you might have cases where you don't actually have everything that you need. So for this, suppose you have a trade-in offer for your car to get a new one for 50% off. How much money will you spend? So for this problem, we're going to try using the 4 steps here, where we'll start with step 1 that says we have to understand the problem. And here, understanding the problem means recognizing that we're going to trade in a car to get a new one at a discount. It's a very basic deal. It's the sort of thing that most everyone will do at some point in their life because their car is going to put on some miles and they'll decide they need to get something different, or maybe they'll get married and have kids and realize a sports car is not quite as useful as a minivan would be.
Is it at least like a sport turbocharged minivan or something? Yeah. You're feeling me. You love it.
So they need to make a trade. Here, that's what we're trying to do. We're trying to figure out how much you might get from that trade, how much you have to spend, that is, in particular.
Now, I know what you're thinking, Stan. You're thinking, can I afford to buy a car like this? Huh? Am I right? Seriously, Stan, you can't afford not to buy a car like this, and I'm going to make it easy on you. When you add this whole thing up, taking into account inflation rate, insurance savings, gas savings, ease, and comfort, you're going to come out $10,000 ahead after making this deal. Well, the prestige alone of owning a Buick Centurion convertible can't even be measured in terms of dollars and cents. Am I right?
And that's kind of a problem. Because in step 2, when we have to make our plan here, we don't have a list price. The list price is never actually given by the statement of our problem here. So without that, we can't actually make a plan. We can't go forward with any plan because there's nothing that we can compare the price to figure out how much we'll spend. Because it's 50% off, but if that's 50% off of nothing, then that's nothing. If it's 50% off of $1 million, it's still $500,000. We don't actually know, so we can't actually figure out that problem that we're trying to solve, which is how much money you need, how much you need to make that trade. You can give them your car if you want to, and you can get money back from them, but even then we don't know what their offer is. So we don't really have anything that we can do here. We're just kind of stuck. And this is the sort of thing you want to pay close attention to, at least in our problems here, is figuring out A, what you're trying to find, in this case the amount that you're going to spend, and B, what you need to actually find that amount, which in this case would be the cost. We don't have that, so we can't move forward. And it's good to know how things can break down, but it's not very interesting. So let's actually take some examples here where you can do this process and get a problem solved, as it were.